All right, ladies and gentlemen, this will be the fastest one of these I'll ever make. I just wanted to update you. It is Monday morning, a little bit past 8 a.m. I've just gotten into my office. The tuning process, so that tune control has completed its task. We have our hyperparameters down here at the bottom of the screen, 1,500 trees, a max depth of 6, learning rate of 0.1. Some of these are a little bit unexpected, and we'll talk about that in a second. Gamma of 0, coal by sample by tree, 0.4. So that's the number of columns by tree, the child weight of 1, and a subsampling of 1. Okay, so what's kind of weird about this? Typically what you do when you construct a decision tree or a big group of decision trees, what we typically find is that the more trees, the better. It's kind of rare that an increased number of trees reduces accuracy. Considering we ran this at 5,000, 1,500, 3,000, 5,000, I would have been surprised if it was anything other than 5,000, to be honest, but 1,500 is yes, somewhat surprising. These are very deep trees. It's chosen the maximum depth. That's probably down to the number of null values. Your learning rate is 0.1, which is a little bit higher than I don't know, not the normal, but it's probably a little bit higher than I was expecting. But all of these are kind of great, right? Because it means that my reasonably mediocre computer is going to be able to handle this without too much, it's not going to take a whole heap of time. Gamma of 0, coal sample by tree, 0.4. Yeah. So I just wanted to let you know that the whole thing is finished. So what I'll be doing is entering these hyperparameters into my what I've called the more realistic tuning grid, and then I'll be constructing all of my trees using these hyperparameters. Now, you could tune for each iteration, which is perfectly reasonable if you have a decent computer. But realistically, the data set, it's going to suggest hyperparameters based on the data set. The data set really doesn't change between iterations, and it certainly doesn't change between iterations. It doesn't change that much for each of the psycholinguistic domains. So I'm going to apply this tuning grid to every single iteration. So if we come back here, we can time how long this is going to take. Have I activated that? Expand tuning grid, beautiful. So now this will use that tuning grid, and we can take a look at the confusion matrix just to see around about how accurate this is going to be. Okay, it is 8:14. I'm not expecting this to take too much longer. And we're good. So less than, what was that, 30 seconds? Now we can take a look at our confusion matrix and see that we have an accuracy of about 60%. So no big change, but we'll be running this for all of the psycholinguistic domains. Yeah, so that's the end of this very fast video. And I think in the next one, we will probably be taking a look at all of the results and talking about them. I think at the end of the last video, I made a bit of a mistake. I'd forgotten the words true and false for some reason, and I was saying correct and incorrect. It's true positive, false negative. Anyway, I'll have to talk about that again because I think I probably made myself sound a little bit silly the last time I tried explaining it. So I will do that again in the next video. All right, take care.